Hey guys, so we're back inside of Houdini and we're just going to go over the last few AOVs before going over deep data, and so that'll be the last thing we do for this tutorial. And so let's go over down here, add a couple more AOVs. We're going to use the good old puzzle mat. Now a lot of people get confused and use object ID. This is not aliased and it is not meant for making mats or masks. This is actually for deep data. So if you need masks on individual objects, either use cryptomat, puzzle mats, or custom AOVs, which let you make them individually. So puzzle mat, if you guys don't know, it's the cleanest in terms of edge control because it only uses channel data, so it only uses red, green, or blue. That's it. And so if we come down here into the options of the puzzle mat, we've got material ID, object ID. So material ID you set at the material level, and object ID you set on the actual objects themselves. So we're going to use object ID for our example, and the red ID, green ID, and blue ID, what this means is what channel number the object ID will be set to. So if your object is set to object ID 0, it's going to use red. And if we move this to 1, for example, and this to 2, our objects with those numbers will have these channels. So what do I mean by that? So let's jump out to our objects and let's make one for our teapot. So if we come up to the redshift object tag on the object itself, you'll notice we have the object ID setting. So we'll keep this at 0. Actually, let's make this 1. And let's make this shape. Let's come on. There we go, render. Make this 2. And let's make this box 3. And actually let's not use 0 because all the objects in our scene have 0. So we'll make this 3. So if we render this right now, what we will get, let's open up our render view, is an AOV where these 3 layers are going to show up as masks individually. And so you're able to split this out in Nuke with channels. And this will give you the cleanest edge possible because there's 0 color contamination since red, green, and blue are in their own channels. So let's come on over here. And actually, in IPR mode, progressive mode, this AOV does not show up. So you need to use bucket mode. Something else to keep in mind. That some of these data AOVs only work when you're working in bucket mode. So as you can see, our teapot here is green because that's 1. Our box is red because that's number 3. And blue will be our other shape that's over here. See? And so what makes this great is that you're able to split these in Nuke into channels. So you see that? It's a perfectly cut black and white mask when we switch to the red channel. If we switch to the green channel, you get a perfect mask. And the blue channel. And so what this means is other people are used to getting black and white masks like this, but then that means you have to write one mask for every AOV, which means larger file sizes, more data has to be written. While if you do it this way, you get basically 3 masks for every one AOV you write. So this saves you file size and still provides you with a clean result. Now, let's say for some reason you did want one object matted out only, and you wanted it to be all white. You could do that with either custom AOVs, or you could just set these parameters to all be the same color. So let's say we wanted our teapot to be white and black. We could just set both of these to 1. And what will happen is we'll only get the teapot, and it'll be black and white. Let's see. No matter what channel we look at. So some people might be used to this workflow, but I personally prefer to use individual channels because that lets me split this in compositing, and so I get more objects per puzzle map. So let's pause that, move that out of the way, and let's switch that back on. We reversed them around, and let's actually make another object ID, and this time we will use, or not object ID, puzzle map. This time we'll use material, so we'll say 1, 2, 3, and so if you go to your materials section, this is you'll have this option available to you, but unfortunately this option is only available in Redshift builders. See this? Where we have our OpenGL and our settings, and here's our material ID. It is not exposed if you're just making shaders at this level. Right here. So it's not under, if you just drop down a material or something like that in map context, it is not available this way. You have to make a material builder first. So if we come up here and we just make our Macbeth chart 1, our gray ball 2, and this 3, and we render this out now, and let's go back to our ROP. We'll have, and actually we need to rename this because it's using the same name, so it's overriding. So let's actually pause that again and call this puzzle mat object. Hit enter, or IPR in bucket mode. And if we check mat, our ground was using the gray diffuse, I believe. Let's go down here. Yeah, our ground. So you'll notice that we've got a ground here, which is all blue. And then our Macbeth chart is going to be separate, and our gray ball is going to be separate. So let's go back to our out, and there we go, green, red, and blue. And then, like I mentioned earlier, you could split it out with channels and get a perfect cut. Cool. So that's how puzzle mats work for material IDs or object IDs. And you could also have them reflect or refract IDs, as in if there's an object. It's actually, I don't have anything that I could show you as an example in this scene, but if there was something behind this glass, you could set it to reflect or refract IDs and it would work. Right now, if I were to set this, I can't get an object behind this piece of glass. So that's how that would work. Right now I don't have anything behind it, so it's not going to work. But if you ever run into a situation where you're wondering, how do I get an ID that's behind a window or something, of an object behind a piece of glass or window, you have to activate this. And this will let you go through glass and select the IDs of objects behind glass. So moving on, let's add another AOV. And let's talk about custom AOVs. And where are they? Oh, and background, like I mentioned earlier, is if you have an HDR in your background. So when you combine all these and you want your background to be its own channel that you can, when compositing, use background. I don't have an HDR in the background, so we're not going to use this. But that's what background is for, if you guys are wondering. What else? Oh, we have matte. So this is if you're gonna make a matte of on an object using. Well, actually, let's use this. So if we come up to beauty and we go up to our object, and let's just say our pyramid. In the visibility tab on our Redshift object properties, in here, when you have our list of properties, there's a section called matte. And this is basically how you're supposed to get shadow catchers. A lot of people use shadow catchers at the shader level. This is the way you're supposed to do it now. The shader level shadow catchers are deprecated. So you're supposed to click this, and then you could change the settings just like you would on the shadow catcher, including puzzle mats, affected by matte lights, apply to secondary rays, the alpha, strength, reflection, refraction, if you want those things to show up, if you want a shadow to still show up. So let's, for example, render this so you can see what the matte does. So we're going to hit render. And I'll just pause this for a second so you guys don't have to see it. And so here we are, the beauty. What happens is that it's cutting out, and we're only seeing the gray in the background of our gray dome light that we have back there. It's not an HDR, it's just a dome light with a flat gray. Now, because we activated shadows and our post effects is on, so let me disable the post effects so that way we don't get the flare. We have shadows on our object still. So that's what enable shadows does. And so if I were to uncheck that, what we would get is basically a perfect matte cutout. So you could have receive shadows for mattes, effect alpha, shadow enable. We'll disable it. And just so you can see the matte, right now we have nothing. And why is that, right? And so here we have the same shot again, and we've got our cutout, but this time it doesn't have the shadow influence. So it's a perfect cutout. And the reason why it's gray is because our gray dome light in the background has that same color gray. And we have the background enabled. Now, you could disable that, and so it'll just be a pure black by going to the options of the object, and where it says show background, you can just uncheck this, and it'll just give us a black cutout. So give it a second to get to it, or it should have given us a black cutout. Oh yeah, there we go. And so it cuts out everything, and it'll just give us a blackout cutout of whatever object has matte enabled. And if we check the alpha, you'll notice that we've got it there. And again, I'm not entirely sure what's going on here. This might be a bug, so I got to report this, that something weird's going on with the refraction there. I'm not entirely sure what that is. So yeah, that's what that does. And I've been informed that there might be some issues with matte that they need to look at, because right now it's not doing anything. So, but I mean, I never use this AOV, honestly. I use crypto matte or puzzle matte or custom AOVs. They're just better for pretty much everything. So I never bother to use this. So, I mean, it's there, but not really one of those AOVs that, you know, people use. It's old. It's been around forever. So let's move on to a custom AOV. That's what we're going to talk about next. Let's go back up to our beauty. And let's switch on over to custom. Now custom's a really powerful AOV, and it has a lot of options and uses. So I'm going to just show you guys a few of them and explain to you a little bit of how it works. So let's come back up to our object and let's disable the matte because I want that to show up in our render. And actually just I just asked about the matte AOV, and it turns out that it's a legacy AOV. So yeah, it's been there forever, and it probably doesn't work in newer builds. They just haven't removed it. So don't use it. Don't use the matte AOV from now on. Just there you go. So I've never bothered to really use it. So, but I thought I'd try to explain it, but I guess it doesn't even work anymore. Yeah. So our custom AOV. So what can we do with custom AOVs? Custom AOVs let you do things either at the material level, or they let you do it at a global level. And what do I mean by that? So in here, when we select custom, we're going to do a custom ambient occlusion. Some people try to use ambient occlusion up here. Where is it? The ambient occlusion AOV, but that's actually broken, or not broken. It's not ambient occlusion the way you would think. This ambient occlusion means that your shaders, if they have ambient occlusion, it will load them. It doesn't make a global ambient occlusion. So if you need a global ambient occlusion, that's what the where is it? The custom AOV is for. And what do I mean by that? Let's jump into our materials here, and I'll just give you guys an example. Let's just do it on the plastic. If we make an RS ambient, why is that not showing up? Ambient, okay. AO. Yeah, there we go. Redshift ambient occlusion. Let's just make this. And we plug it in to our overall color. And that we'll just leave it like that. And so what this will do, and let's actually use an ambient occlusion AOV just so you guys can see it too. Let's add another AOV, come down here, and we'll add ambient occlusion. And this is fine. Most people assume that when you add the ambient occlusion, it's going to give it for your entire scene, and that's just not the case. So, but if we wanted it for the entire scene, this is what the custom AOV does. So if we come in here, and where it says default shader, you plug in a shader, not a full-on shader, but like a node, like ambient occlusion, the one we just made, right? We just plug that in, and now we render this. So let me render this, and I'll pause it while it renders so you guys don't, save time. So I'll be right back. And so we're back, and you'll notice that, and this is a low resolution render just so you guys know, so we could kind of make these iterations a little faster. There's ambient occlusion added on this corner here of our triangle because we added that node, right? So if we check the AO, that's the only thing that comes up. So that's how the regular ambient occlusion node works. It only works on how to composite your beauty. So if your render or shaders were using ambient occlusion, then they will appear in here. That's all this node does. It doesn't give you a global ambient occlusion. Now, if you just add your ambient occlusion up here to the custom shader, you would think it would work, but it does not. In Maya and other apps, I'm not entirely sure, you could just directly point it to the node. I've requested this feature, so hopefully in Houdini we'll get it. But what you have to do is actually build the VOPNet to have this option. So I'll just copy it, right? And let's make a material builder. And we'll just call this custom AOV AO. We'll jump in here and let's just paste it. And if we plug this in just straight into the surface, and then we reference this node, so let's come back up here and custom AO AOV, what will happen, and let's enable our post effects just because why not. Here we go. Now we've got a global ambient occlusion. And so that's what that does. And yeah, I mean that's basically that's all it does. Cool. So what else can custom AOVs do? So let's actually get rid of the ambient occlusion because we don't need this since we're not going to be using it on our shaders. And let's just pause that. Let's jump out here into our material and let's get rid of that ambient occlusion on our plastic because I don't want it on there. Let's make sure, okay, overall tint's fine. Okay, so let's say we wanted to make another custom AOV. Let's just duplicate this and we'll call this V-Ray normal. So some people need normals in V-Ray space. And what does that mean exactly? V-Ray uses normal maps or normal AOVs in camera space, while Redshift uses world space or object space. So let me pull up the V-Ray documentation so you guys can see this. And so if we bring up the documentation, you'll notice the normal color generation. It says the x-axis runs left to right to the camera viewing angle, right? So it's using camera-based normals. This is the normal map people, when they think of normal maps from V-Ray, they think of this. Okay, and so if we look at Redshifts, and I think it's because I didn't actually generate it, so let's let's render real quick so you guys can see the difference. You'll see the difference, and that's because this is using world space, this is using camera space, and the direction is different of the color. And so people ask, how do I get a V-Ray style normal map out in Redshift? So this is how you do it with a custom AOV. So let's actually make a new custom AOV. Let's actually quick mark this so we can get back in here quickly. And we'll call this custom V-Ray N for V-Ray normals. And so we need to bring in another shader in here. So we're going to load up the custom V-Ray normal. And let's come back in here. And what we need is the state node. The Redshift state can output all this data we need. So let's squeeze this over. And so it's got normal, normal no bump, normal geometry, tangent, ray origin, ray position, etc., etc. And so what we need is to output the normal. But we also need it to be in a different state. So right now it's in world space. So if we were to render this, let's just render this real quick again. And we compare the two, they're pretty much the same. See that? The difference is that the Redshift version goes into negative space, but the color and everything is the same. So what we need is actually camera space. So we switch that over. And now we're in camera space. So if we render again, our render's now in camera space, but the colors are different from what we need. And so in order to now get the right colors, is the reason is because we need to remap our output. Since it outputs negative values, that's what these black colors are. These are negative values. If we come over to the pixel picker and we pick a point and we come down to our custom section, you'll notice we have negative 0.7, negative 0.4, and so on in this area. And yeah, that's why. We don't need those negative values. What we need to remap this, V-Ray uses a remapped version that's in 0 to 1 space. So that's what we need to do. So how do we remap this output back into 0 to 1 space? And that's what we got to do for our next step. So let's zoom out a little bit, expand our shader graph, and use some math nodes to remap this. So the idea is, how do we remap these ranges, right? And to do that, we have a special math node, color, where is it? Remap, no. Color, where is it? Change range. And so what this lets you do is edit the ranges that is output by whatever color is being input. So we're inputting the normals, and we know that Redshift is using negative numbers, so we need to bring those back into 0 to 1 space, which is fine. So if we make this negative 1, negative 1, negative 1, what this will do is it'll remap negative 1 to 1 back into 0 to 1 space. So if we render this, let's just render. We're closer to what we wanted. But V-Ray also flips the color location inputs and outputs. So I'll include this for you guys, but it's a sphere, so you could see the way that the color is being mapped in V-Ray. And so right now our sphere is not mapping like that. You'll notice that the green is up on the upper left and the red is on the lower right. So it's reversed. So what we need to do, so let's pause that, is we need to remap the normal X and Z directions. So it's not only we have to reverse it, basically, is what I'm saying. And so in order we have to reverse these, we just got to flip the 1 up here and the negative 1 down here. So let's make this 1, negative 1. The Y is okay because green is up and down. That's fine. But what's flipped is our X and Z, which is our blue and our green. I mean, our blue and our red. So R, G, B. So G is fine. We need to reverse the red. And we also need to reverse the blue. So now, if we re-render this, we have regular V-Ray style normal mapping. See, the sphere is correct. The angle that we're looking at it is off because this is head on. So if I were to, let's just move the camera down and look at the sphere head on. And oops, actually I should not have moved that because I'm using a look at camera right now. So let's use just regular perspective here and move down. And let that render. You'll notice that they're the same. The color hues might be a little different, but that's irrelevant. The RGB data for normals is the same. The direction that they're pointing. So yeah, there you go. These spheres have the blue and the green from the right, and the stronger green up top, the reds on the left and bottom. So X, Y, and Z, or X, Y, and Z. And yeah, they're good to go. So that's how you guys can make a V-Ray style normal map. So just by changing the range and using the state node, and you could use camera, you could use normal with bump or no bump, and so on. So there's different outputs you guys could choose to accomplish what you need, and you could change the space. But like I said, V-Ray uses camera space. And so this is what you, if you were to just make a normal map AOV in V-Ray, this is what you'd set up to do it in Redshift. And you know, you guys could save this out as a custom HDA and use it in the future if you want. So cool. That's how you make a V-Ray style normal map. So let's jump back into the camera and let's switch on over to making another special AOV. Let's just pause that. So let's say you needed a random color puzzle, or not a puzzle, a clown pass, for example. How would you go about creating that? And so that could be, let's just duplicate this again. And we'll call this clown pass. And let's just delete all these. And so to make that, we're going to actually need to use user data. So the Redshift user data color. And we'll plug this in. And what we're going to use, just because it's easier, since it's already a parameter built into Houdini, we're going to use CD. So if we come up to our objects, and let's just dive in here. Let's make an attribute randomize. It already comes with CD. We're going to just plug it in. And we're going to copy paste it. I know it's influencing the viewport because that's what CD does. It's just for the viewport. Redshift doesn't actually render CD unless you have it applied as a user data shader. Obviously, in your own if you don't want it to show up that way, you would use a different parameter instead of CD. You might use, you know, custom AOV or clown pass or whatever, right? Let's come down here. And you guys could script this if you needed to do this to tons of different assets, or if you had instances, this will also work. And actually, I don't think it'll work on volumes. So no point in doing it on that. And where's our ground? Here we go. And so right now it's applying it to the points. So if I were to render this, and actually let's go up to our AOVs because we need to make a new one. Another custom. We'll call this custom clown pass. And for the default shader, we'll use the clown pass. So if we render this, let's hit render. And we come down to our clown pass, we'll get all the rainbow colors. Right now it's being applied per point. But just an example so you guys could see that you could get data on a per point level. And I forgot to add it to these objects, so they're going to just stay black. But this lets you do, with a custom AOV, pretty much anything you guys can imagine in terms of an AOV, data AOV. So let's come back into our object, and I probably should have done this originally with this in mind, because now I have to manually come in here. But instead of points, I'm going to do it at primitive level, which is per polygon. Could have it on per detail, per vertices, and so on. We're going to just do it detail, and come in here. And I'm not sure which object this is. Okay. And if we were to render this out, now everything is the same color on a per detail level, because it can't randomize without a PT num or something like that, a point number. So, or you could do it by, like I said, polygon primitives, points, yada yada. And so you could use this to make a color mask if you need, for some reason, across everything, and you don't want it on certain objects. Same thing will apply if you're doing instances, which I don't think I have anything in our scene with instances, which might be a good idea to add. Oh, and if you adjust the values, you know, it's just like any attribute. This would be XYZ, RGB. So if I were to make this 1, let's just see what happens here. And I hit render. This object should be a different color. It should, but yeah. So you can see that now it's white. And so those values that are being generated, if you go to your geometry spreadsheet, you'll see them here on detail. CD, RGB. So it's making 0.8, 0.9, whatever, and 1. And so it's almost a white color. So it's not all the way white, but it's basically almost white. And, you know, you guys could randomize this all you want, change the values, do whatever you guys want for this. And if we were to make instances, let's just make an example of that. since that is something that Cryptomat cannot do, which is kind of a problem. Oops. Let's delete these. And our ground, well, we'll leave the ground one color for now. And let's make an instance node. And we'll just drop down a grid. And we'll move this into a position. Let's just say up here. And actually that's fine, I think. We'll just paste the attribute randomize. And we'll just say CD for points. And for our instances, let's just make a new box. Actually, no, we'll just use the jade box or whatever we've got. Or the triangles. Yeah, we'll use the triangles. So let's use the Platonic Object 1. Full point instancing. They're a little bit big. Let's just do a randomize. P scale. And let's freeze our viewport display. Let's shrink these down just a little bit. Okay, cool. So this should give us all these little triangles. And because we also have the CD attribute in here, at the point level, it should give us random colors per point. So let's render. And there we go. So we've got only our ground, which is that solid blue color. And in the same AOV, each instance is its own random CD color. It's like a bootleg crypto mat, or a clown pass as people like to call it. Now, obviously if you scripted this or you did it on a one-click system, that way you don't have to jump into every object, that would help immensely. So you could avoid doing all that one by one. But for now, yeah, if I'd have never made a script for it. I just use Cryptomat. But some people ask about how to do this, so this is how you do it. And the reason why is because if we go to Cryptomat, they're all the same. See? Because Cryptomat does not differentiate per point instance data. It treats instances all the same. So this lets you kind of treat each instance as its own asset. Cool. We'll just hide that for now. And so that's an option with custom AOVs. Some of the things you could do with them. You could do more stuff. And you could actually do things at the shader level instead of overriding everything globally. So right now we've only been doing global overrides. So what happens if you want to do something at the local level? Let's just add one more. We'll call this custom. And again, you could pick a shader. But this time, we're going to pick a shader of an asset we already have. So let's come in here. And we'll do the ground again. And we'll come back out. So let's say you didn't want to globally override something and you only want it on a specific shader. So we just want it on the ground. That's it. And we want the ground to be, I don't know, constant color, black or something. So we'll make constant, or we'll just make it pink. But you don't want this node to affect the beauty render, because you just want it for the custom AOV. You don't want it to do anything to our beauty. So how do we do that? That's what the special AOV nodes are for. And actually, instead of using the color constant, let's use the wire color or wireframe. So we'll use this, and we'll just use black, and our wireframe will be pink. And so this node makes a wireframe of the geometry in our scene. And so in order to get this to feed in but not actually affect our shader, there are special nodes under tools called redshift store color or store integer or store scalar. We're going to, as you guys might know, just if you're used to Houdini, integer being integer values, so whole numbers 0, 1, 2, 3. Scalar is float values, aka 0.1, 0.2, 0.56, whatever, right? That's scalar. And color is a vector, it's RGB. So 3 floats. We're going to use that because this has multiple colors. So store color to AOV. And you'll notice in here that there is a beauty input inside of this node. So what we need to do is plug in our beauty. Move that to the side here. And then there's an out color. So right now, and as soon as we plugged in the beauty, this new little option came in, the AOV name and AOV input. And so what do these options do? The AOV input is what you want to write. So if I plug this in, it wrote it into the AOV input slot 1. And actually, no, let's bring in the constant. Let's do that so you guys can see what multiple ones look like. And so this constant will make the ground all black. And we'll make that AOV input 2. And as you keep adding them, more input slots open, and also the AOV name option gets added. And so what does AOV name mean? The AOV name means the name. Let's hit the one, or let's actually dive back in there so I could quick mark this. Let's hit the 1 key. And so what this means is that you don't actually have to put a default shader in here. So if I get rid of this, it'll instead be writing based on the name of our custom AOV. So we're going to just call this ground wireframe. And actually, let's go up. Let's make a new one. And we'll call this custom again. And we'll say custom alpha. We'll just call this custom alpha. So it'll be black or white. And so you don't have to input a default shader. This is only needed, like these ones, if you planned on overriding the entire scene. But you could do it per shader and point to this AOV. So custom wireframe. So let's jump back up over here. And in our store to color, our wireframe was the first AOV, so we'll call this custom wireframe. So let's start rendering here. Move up our render view. And you'll notice that the wireframe data did nothing to our beauty. Our beauty still looks like our beauty. But if we come down here and check out ground, or actually, oops, yeah, no, I named it wrong. Ground wireframe. And let's re-render again. There we go. We've got our wireframe using those colors. Black for the inside of the polygons and this pink for the wireframe. Pretty neat. And so we'll call this down here custom alpha, since that's what we named that one. And so what that's going to do is give us a constant. Let's actually make it white, because I think black is the lack of. So we'll make this white. And you could actually point multiple objects to that same AOV. So let's say our Macbeth chart. Let's do another constant. And we'll make this color, I don't know, purple. And for this, we'll use the store color to AOV. Once again, we'll plug in our beauty. And we'll plug in our custom AOV. And again, in here, we'll call this custom alpha. And now if we render, and we go to our custom alpha, we'll have the white from the ground that we added earlier, and we'll have the purple from our color constant inside of our Macbeth chart. So this lets you make any kind of custom AOV color or data channels, whatever you could think of. And you could do it per object inside the shader level, or you could do it globally across everything. So yeah, the possibilities, there's just tons of them. You guys could, you know, play around with the inputs and outputs and what kind of data you want to get. You can get curvature, you could get, you know, the custom alphas, you guys can get clown passes, you guys could get the V-Ray normal styles. I mean, just tons of options. And yeah, I'm gonna keep this, but I'm gonna kill the color constant. I don't want that one. Actually, no. Let's keep that, and let's get rid of the wireframe. And you can write the same thing to multiple AOVs too. Just how you guys see how that's connected. Even though it's the same output, it's writing to different AOVs. You could have it do that. So there's just a lot of options and control when it comes to this. And let's just get rid of that. Cool. And we'll just get rid of it for our Macbeth chart. We don't need it. I'll keep the ground split alpha though. It seems useful. Another example of a custom AOV. We'll call this custom, I don't know, curvature. Actually, no, I'm not going to bother. You know, this tutorial is already kind of long, and you guys get the idea that any kind of curvature, normals, ambient occlusion, all this stuff can be used with custom AOVs. All those special nodes, the math nodes, all that stuff, the state node, everything can be used for different purposes, just like you would shading, except this outputs to an AOV. So you guys can see how that would be very useful. So let's actually kill this too. I don't want the clown pass. We'll kill the curvature. We'll keep the custom alpha. And I think for now that's enough. And I think that just about covers all the useful AOVs. We've already done world position, Z depth, motion vectors, puzzle mats, object ID. I'll talk about in the deep section. All these. We haven't talked about shadows, so actually let's make shadow. Where was it? Shadows. Nothing you can really do about it, just shadows, that's it. Pretty simple and straightforward. And I'll talk about how you can use it in Nuke. And like I said, matte is deprecated. I don't know why it's still here. I asked the devs. They mentioned don't use it anymore. So slash this. We already know about all the other ones. Ambient occlusion, the volume ones. Translucency is basically one polygon thick stuff like leaves. Nothing special about them really. Object position is usable, but I don't know a pipeline in Nuke that would use this, but I'm sure there's someone out there that needs this. And background, I mentioned, is if you have an HDR in your background, that's what this is for. I don't have one, so I'm not using it. Beauty is obviously another beauty pass. Crypto matte. IDs and coverage. This isn't supposed to be available yet. It's for future tech. It's going to get added, but it's so don't use this. I don't know what it's going to be for, but I've asked the devs about it, and they just said that it's for the future. But it's already exposed in some of the apps, but don't use it. It won't work in the current public builds. And custom AOV we just talked about for the last 40 minutes and all the cool things you can do with them. Personally, I only ever use the regular AOVs, motion vector, Z depth, custom, and crypto matte basically for most purposes. And occasionally I'll use the world position and normal for point clouds instead of having to use deep. So cool. Let's render this out, and I'll talk about deep AOVs next, and then we'll finally finish everything up in Nuke so you can see how all these AOVs come into play. So yeah, I'm gonna come back out, go to our object, jump into our top net. Let's close this. Let's save, and we're gonna fire off our render and let that go. So I'll be pausing this while we fire off all our frames, and I'll be back. I realized I kind of went pretty quickly over how to make a clown pass, so I wanted to come back and show you guys how to do that. So with the custom AOV, we're going to just load in a custom shader. So let's go to matte, and we're going to just use the custom AOV clown pass. The user data is going to be CD again. We could use something else if we want. So we're going to load that up. Custom AOV clown pass. And there's several ways to get random numbers. Like I said, for instances to get the clown pass colors, you want to use ptnum or something similar. For entire objects, though, that are separate, you're going to have to... I'm sure there's a way to automate this with Python, but if we're not doing it that way, we're going to have to do it manually. So let's actually delete this attribute randomize here, and we're going to make a new attribute. And there's two ways you could do it. You could do a color and just plug this in,
And instead of a constant, you pick random, and you just change the seed. And instead of class by point, you do it by detail. And that'll work. That's one way. So you could do like 5, whatever, right? Another method, which I think is a little better, is to make a custom attribute VOP. And this will kind of automate it a little bit. It won't work always, so just keep this in mind. It won't work on instances, so for instances, you're still going to need to use ptnum. And we're going to plug this in here. And we're going to dive in. And the attribute we want to use is, instead of ptnum, which is the point number, which is using as a seed for the random number, we're going to use number of points. So I'm going to assume that you guys are working with objects where if you're duplicating an object, you're instancing it, so you guys are going to do it using the ptnum method. And so the assumption is that each object has different point numbers, right? Like this isn't the same points or vertices as this, as this, as this. So how this is going to work is based on how many points your object has, it will randomly create a color. So if we come up here and type in random, we're going to make 3 of these because we're going to randomize our number of points 3 ways. So we're going to plug this in, plug this in, plug this in, and then we need a vector to float, I believe. Actually, no, wrong way. We need a vector. Where is it? Where's it a float? Vector 4, float to vector. There we go. We need a float to vector. And so this is going to combine these 3 outputs, X, Y, Z, or RGB if you want to look at it that way, into CD, which is our color. And so if we look at our attribute or geometry spreadsheet, actually, why is it not? Oh, it's not running over the points, that's why. So select our attribute VOP, and instead of points, we want it on our detail. Now you'll notice RGB, but the values are the same. So if we come up here, the problem is that this is giving it the same random number, and so it's creating the same randomness. So we need to multiply it with something else that's random. And we could use different things. Depends how you guys want to do it. You could multiply constant, or just multiply with something else that's random, which would probably be a better number generator. So if we multiply, and we multiply it with something else like ptnum, and then we plug that in, we should be getting a different number. Yeah, so now our B is 739 or whatever, right? And that's because we're multiplying with another random number. So let's scoot this over. So what we're going to do is the same thing. We're going to multiply, but instead of using the same ptnum, we'll use a different method. So that way it's picking up completely different inputs to multiply with. So let's cut our ptnum there and our ptnum here. And instead, let's use, I don't know, let's see what happens if we plug in ID. Oh no, ID is giving us the same as the ptnum. If we plug in P, that gives us a different output. And here we could multiply a constant if we want, or a primitive number. Let's see what we get. Yeah, so now we've got 3 completely random numbers being generated, and based on the position might not be a good idea if we move the object around. So let me actually kill position. Let's do something else that shouldn't change too much. Even though ptnum and these might change if your object's changing shape, it might give you problems also if it's like I don't know, some sort of simulation or something. But like I said, if your guys are going to be using point scattering and stuff, you'll be using ptnum to generate the random CDs. Let's just do a constant. And we'll just do, I don't know, 15.5. Plug that in. And that gave us some other random number here. And with that, we should be getting a different color for every object in our scene. So if we jump back up, come down here, get that, paste, oops, let's plug it in down here. That won't work for our volume. But for solid objects, it should work. Come in here. Actually, that's giving, oh no, yeah, that's okay, I think. And our ground. So that should be giving us a whole bunch of different colors. And actually, let me save this as a different name for our file. We'll call this Clown Pass Custom AOV Example. And so now if we render this out, it should work. There's our beauty, and here's our custom. Yep. So now we've got random colors. And so depending on how many points your object has, it will randomly pick a color. Some of them might be a little close, but in general, they'll be all over the place. Pretty neat. And obviously you guys could make that into a shelf button that gets assigned to your object automatically, or you know, you guys could come in here and bind it to different stuff or add different parameters that you could expose at the top level. There's just a bunch of options you could have, you know, for inputs and outputs and whatnot. For example, if we wanted to get rid of the constant and we just promoted this parameter and we jump up a level, we would have that here, and we can make this into a custom HDA. We could call this the seed or whatever, and as you can see, it will change the colors. So if we highlight this and we run an IPR, it should, I guess not, huh? Oh yeah, it does. It'll change colors. We just need to use larger values. So if I use like 100 or something, 500, 60, whatever. These are all in the blue range. And if we wanted to, we could have each of these another promotion here, another promotion here, and it could all be controlled by a single slider. So let's just say we promote this parameter, promote this parameter. We could have 3 different seeds. And you could just be shifting around, values if you need to change it specifically. So yeah, you guys can make an HDA out of this. I might do it myself and make it a shelf icon that just automatically assigns it to each object I select. I'll let you guys know and post it in the section for my assets when it's ready, if I do end up making it. But yeah, hopefully you guys now understand that's how you can make a clown pass really easily for your assets in your scene. Won't work on volumes, unfortunately, but regular objects, it works. Cool. Alright guys, we're back inside of Nuke, and since I rendered out all the frames, let's actually load up every frame. So let's edit this. And let's do an original range and hold of 10. And we should have our animation going here. Notice how our card that we added earlier is matching our rotation, which is pretty sweet. Cool. Now, since we were making a lot of mats and masks, how can we use one of those mats or masks to, I don't know, color grade, or to, for example, push this card behind an object like this cube here and cut it out, so it looks like it's actually behind it instead of on top of it. And so if we come down here, we could cut it out after our scanline render if we wanted to do that. And we could actually color grade specific things further up the chain. So we've got our post effects AOV added up here. And we could actually do some color grading before the post effect. Oh, actually, no. Let's do it after. And so we'll color grade after our post effects AOV, which I believe is somewhere up here. Yeah, somewhere up here. And you know, this is probably why I should start using notes to organize this, but whatever. Let's do it. Let's check what we got here. So this is before our card, but after our fog. So let's do it before our fog. Let's move this down. And yeah, let's just move this down further this way. And so let's just drop down a grade node. Actually, drop down a grade node here. We'll plug that in here. And the Z depth doesn't matter. We don't have to. It could come in from here or from here at any point. It's fine. So we'll just split this way, and we'll do our editing here, and we'll keep our Z depth down here. And so let's check everything out from our grade point. So if we color grade everything, we can color grade. But let's say we wanted to color grade a specific thing, like I don't know, this cube. There's several ways we could pull that in. And if we come back down and check for, actually let's come over here and look at our puzzle mat. Here we go. We can see that that's our blue channel on our puzzle mat OBJ. So let's jump back up here. And so for our mask, we could either split it out and edit it and pipe it back into our mask input, or we could load it in directly. I'm going to try to load it in directly and just see what we get. So it was our puzzle mat object blue. And now let's check that. Yeah, so you can see that there's our composite. So we can make our little cube a little brighter. We could add a little gain. And maybe shift the hue. Let's make it this purplish blue. And as you can see, if we zoom in here, I mean it's perfect. It's only influencing just our little cube here. And we could tone it down. We could the D key. Make it a little blend between the two. Cool. And so we just edited that data right there, just for this specific asset. The same thing can be done So you know that's using your puzzle mats. You could just load them in per channel. Really useful. Now, CryptoMat, if we come over here, lets you, it's basically a super puzzle mat, but it can have issues when picking out overlapping assets that have depth of field. It is not always perfect, but most of the time it's pretty good. So how CryptoMat works is you select your CryptoMat node, and you could have your picker. When you activate picker add or picker remove, it adds or removes objects. So let's pick this color back here, for example, this object. And so this is our I don't know what shape it was actually, but the picker works by, if you hold control and you click, it adds things, right? And so if we look at our output, it's gonna output as an alpha, and so you could preview it as the edges, colors, or you could look at it as a mat only, which is black and white. And so this lets you kind of preview it, but the output is actually outputting to the alpha, and you can see that there it is. It's outputting directly into our alpha mat. But you could have it output to other outputs. And you could unpre-molt. You could clear the selections. And that's what that list is. So if you had custom names, when you were using CryptoMat, you could type them in here. You'd write in like whatever box or something, right? And it would select those boxes. We don't actually have anything named in here. It's just using the custom automatic data, so it's not going to work with that. Yeah, so let's actually pick this object back here. So once you have your picker add mode selected, you hold control and click. That's the picker and nuke. If you want to remove something, you switch to remove mode and control and click. So we're going to select this object back here. Or actually, no, let's select the teapot and let's remove that. Or maybe we'll select them both. Let's do both since they're both metallic. And cool. So if we check out mat only preview mode, you'll notice here's our mat. And if we switch over to alpha, we've got our alpha. In RGB A mode, alpha. Pretty sweet. So how can this be what's it called, useful for us, basically? How can we use this? Many ways, many different ways that we could end up using this data for masking, for grading, but usually it's used for masking or cutting out things from our composite. So just switch back to RGB, and that's what we got here. But that's the data that's being output in the alpha. So just so you guys know. And now we could use this for any number of things. So let's bring that down. And we could shuffle this into our node structure here using a shuffle copy, or we could just plug it back in directly into our grade node. Different ways we could approach it. So let's drop another grade node. And we're going to plug that into our CryptoMat. And so let's check out what's going on here. And so if we look at this, this is our alpha that we have in our scene normally. But our mask on our grade is reading the RGB A alpha, which if we come back to here is this. We don't want to read this data in. What we want to read is the alpha. If you hit the A key, hotkey, that's how you get the alpha. So what we want is this, which is the alpha of our cryptomat. So to read that in, we're going to have to switch on over here. And we could either shuffle it out or read in the data differently. So let's switch back over to our beauty. And if we just increase the multiply, oh, I just realized that our, what's it called? We're not loading the animation of our cryptomat. So let's actually come in here and make sure this is the animation, not just frame 6. Let's make this frame 10 frames, 10 frames. There we go. And so we could, do different things here. Let's say we just wanted to increase the brightness of our teapot. And what's cool is this data is always live. So I could come in here and let's just remove the that piece. And so if we come back, now it's not affecting this, it's just affecting our teapot. We can darken it more. I want to make it a little brighter. Give it a little contrast. I'll bring up the black point a little bit. Okay, cool. So that's our little edit right there on our teapot. Now let's say I wanted to influence this piece again separately. Could always make another cryptomat and shuffle that out or plug it in again directly. So for example, if we let's say we wanted to get rid of our, where is it? Down here. And Nuke just crashed. Alright, we're back. Luckily Nuke auto-saved for us. One of the great features that Nuke has. And so it auto-saved right before the crash. I'm going to check to see if it doesn't do it again. So I'm going to pause this because it might just crash again. I don't know if it might be a bug. And luckily it didn't crash. Okay, so we're back here at this stage. And we're merging in. And actually, let me see. It appears as though, nope, yeah. Okay. That looks okay. And actually, no, we needed this to happen on this path. So let's disconnect that, bring that down this way. Bring that up over here. And bring the B into here. And there we go. Yeah, the order was just flipped. And we'll just keep the fog over here. And we'll do our grading on the right side before merging it down. And let's save this for now. All right, so we've got our color edits on our objects. We've got the Z depth and everything else going on. Let's see what happens if we read in our card. And let's actually move our card into place. So if we select our card, and let's try to cut it out so that it's behind our box right here, right? And so normally we can't, it's not being cut. So we need to actually use a mask to cut this out of our composite using a mask of this box here. So how do we do this? We could do it several ways. We could load in our CryptoMat data and pipe it in as a mask into our merge after our scanline render. So we have our mask input. Or since we conveniently made earlier our puzzle mat on the blue channel, we'll use that. So if we go on top of our merge here, let's double click our merge. And basically if we were to disable this, it would get rid of our scanline render checkerboard, right? So what we need to do is cut this out using our mask. So if we were to come over here and again look at our puzzle mat for objects, you'll notice the blue channel will give us that mask. So on mask, let's switch on over, look for puzzle mat object blue, and it cut it out, but it cut it out on the object. We need the invert, so we just hit invert, and there we go. So now it's cutting out and it acting like it's in front of this piece. So if we rewind it and let's just press play, it will work exactly like if it was in that location. See? And it follows it perfectly. And of course we could, further edit this, the location of it. Maybe it's too close. Let's scoot it back a bit. I don't know, right? We could rotate it. Let's rotate it the other way. Let's do 0. And yeah, it looks like it's in the spot it should be. And our object's cutting out in front of it, so it looks like it's behind it. Pretty neat. And again, we could have used our CryptoMat, just made another CryptoMat node and selected only this cube and pushed it into our mask. Or shuffled that layer in and then selected it this way with whatever we called it, CryptoMat cube or whatever. Pretty cool, pretty powerful stuff for editing and compositing everything together here. And actually I want to do another grade, so let's do another grade, and we'll make another CryptoMat here. So let's drop down another CryptoMat. Here we go. And we'll unhook this, and we'll keep them separate. And let's just check out our CryptoMat. Let's pick our Macbeth chart and our two spheres because they feel a little dark. Let's come back down this way. And we'll use this data to feed into our mask. For our grade, let's select our grade, and we'll increase the brightness a little bit on that. Just punch it up so it doesn't feel too dark. And actually we'll drop down a color correct. We'll also use that same crypto map mask, and we'll drop the saturation just a little bit. We could go further, but something like that. Cool. And let's save that out. And yeah, I think you guys kind of get the idea. Using these layers, we could just start, adding more and more and more options and details, and there's just so many things we could do using these methods that truly just give us a lot of options. So we've got like our custom alpha here. So let's say we wanted to grade the ground, and let's or is it just in the alpha? Nope. Guess there is no data in there. Yeah, I must have accidentally deleted it when I rendered it. Or actually, we've got our custom AO. So it's kind of poorly sampled, but we could add this on top the same way that we added the Z depth, wherever that's at, over here. Or we could use it to grade down our darkness there. That could work too. So let's actually try that. So let's go back to RGBA, and let's do another grade node, and this time we'll use our custom ambient occlusion. And actually red might work, it might not. Let me check that again. Shouldn't matter. Yeah, since each channel's it's just black and white data. So let's use, where were we? Our custom AO red. And you could use that to darken things. And actually let's invert it so you can see. We can use that to kind of bring in those shadows back in on the ground. I personally don't like it, but just something you guys could do with it. So let's save. I think we've kind of gone over all the nodes, or the AOVs, I mean, and how you could use them as masks or to cut out stuff. The only thing really left now is to talk about deep data. So we're going to move on to deep data next. That will require a new scene because the AOVs, you can't make all these AOVs with deep data. Deep data is its own thing, and only a few AOVs are supported in Redshift. Redshift does not support volumes in deep AOVs yet either, which kind of sucks, but hopefully they said they'll add that soon. And that's one of the really powerful things about deep AOVs that people use in the industry, is for volumes to push objects into them. And so deep data is basically this thing, a point cloud of data, except a lot more advanced. It actually uses the deep pixel points, and so you could bring in objects, and let's say I had a volume or something, I could push it in and it would look good. Since we don't do deep volumes though, you could use it for geometry. So what do I mean by all that? We'll move on to that next. So let's save this scene out so you guys can play around with everything. And actually let's move back down to the bottom, and I'll actually get rid of the tone mapper. Let's just keep it regular. for now. And yeah, we've got the defocus. I think we're missing the post effects. Not entirely sure. Oh, when I saved it, I forgot I disabled it in the render view in Houdini. Let's see. Oh no, it's in here. Seems like it's missing though. Pretty weird. Let's see if I jump back up to the beauty. I think it's actually disabled in the batch render settings, which might explain why it's missing from our beauty render here. Unfortunately, I think it is disabled. Yep. Oh well. But I showed you guys how to do that earlier, so it's not really a problem. But yeah, it looks like the post effects got disabled when I last rendered it out. But, well, oh well. Things happen. You guys know how to split it out using subtractive compositing to get the flares and stuff back. So anyways, let's oh no, they're there. It just wasn't bright enough. Cool. So let's press play just to get one last preview before we go to deep AOVs, the last part of our tutorial. And let's let this bake out. Neat. So yeah, you guys could see how we used our color grading, our mask to color grade. We split out the post effects and all the pieces in our render. We edited using crypto matte, puzzle matte. We cut out our asset that we added into our 3D scene. So, you know, this doesn't have to be a card, guys. This could be anything. This could be a 2D smoke pile, a 2D flame, whatever, put on a card and animated and put somewhere in your scene, and it'll feel like it's in the right location, which is really, really powerful stuff, especially for people that are matte painters. This is how you can add 2D assets like fires and stuff into your shot, even when the camera's rotating around, on top of, you know, projection painting and stuff like that. Yeah, so let's move on to deep AOV. So we're going to get back into Houdini. I'll save this scene out, and we're going to have to make a new scene, which will cover only deep. So I'll be right back. Hey guys, I realized that I didn't explain the shadow AOV and how to use it. So actually let's do that. And I'll also mention that I brought back in the, where is it? The custom alpha. So let's just use that real quick. So this is a custom AOV that we had earlier, and I just forgot to add it when we rendered. And so let's do a grade, and we'll just switch over to the custom alpha. Where are you? Custom alpha. It could just be red for a mask, and we can increase, let's just say, the gain. And this lets us increase the color of our ground. It's kind of cool, or we can decrease it and go the opposite way. We'll just increase it a little bit. So there you go, just so you guys can see how I use that. And so anyways, the shadow AOV, if we switch over to shadow, it gives us this. And so it might be a little confusing as to what this is actually. And so it's basically revealing our diffuse where our shadows are. So what do I mean by that? How can we use that, right?
And that particular AOV is something that needs to be multiplied on top of our diffuse filter here. So if we wanted to split this up, since we're already doing it on this area, let's just copy this. Let's paste it down. Plug it back into our beauty. And let's move this down more so we got a little more room. And actually this is not plugging into anything, I don't think. So we'll just unhook that. And so what we need to do is combine these two and then add them back on top of all of these using the plus, but we want to do it separately so we can control it. So let's double click this, let's switch over to shadow, and that should be fine. And we're going to use another merge. We'll plug this in. And great, we crashed again. Alright, we're back in Nuke. I'm going to load up from this point. I think this, I don't know what's causing it to bug out, but it might be the graph. I'm not sure. So I'm just going to load it from this point on so you guys can see the difference anyways without the fog and all that stuff. And so we've got our shadows, and we're going to merge this in. And so if we look at this and we connect this over, what we need this to do is to actually multiply. And actually that's going to give us a problem. We need this to be a separate operation. So let's unhook this. What we want to happen is it comes up to here. For diffuse raw, diffuse filter, and I'm not sure why it's acting up. I think the order's off, so need that to happen here. Or do we have to reverse? Huh. Why is our diffuse filter not working? This is multiplied. There we go. There we go. Okay. And we need this to occur on its own. So if we look at this and we combine it here, this is what we get. And so this step, let's just move this to the side. Let's move it way out here. Then needs to get plussed on its own. So what do I mean by that? We'll do a plus on top of all of this. So if we drop a merge, and we'll plug that in here. And instead of outputting only down to here, we'll have it output this way also.
And actually, I think that's the post effects AOV up on the side. So let's unhook that, plug that back in this way. And this needs to be plus. And where were we? This is out. And then we plug this output, this A, into here. And let's just see what our result is. So yeah, you'll notice now we don't have our shadows. See that? So this is our shadows built in. And then at this point, after the multiply, we could add it back in. And so what this does is it kind of gives us the removal of our shadows. So then we could lower that amount. And then now it's like what we had up here. So if you look at the two, let's switch between the two so you can see the difference. And let's increase our mix. You'll notice, there we go. And so it kind of looks a little confusing. But the idea is that you add the diffuse filter to the shadows with the multiply, and then you plus it back in to the rest of your AOVs separately so that you could control this using the mix. And so if you mix it all the way, it's back to the full shadows. If you want weaker shadows, you could do that. Or you could even add a grade. So let's say we're right here and we drop down a grade node. And let's turn that back on. Now we've got blue shadows. If we wanted to give things a little bit of a bluish hue, for example. And yeah, I think you guys kind of see what's going on here. So cool. Now you guys know. Alright, so now time to move on to deep. So we're back inside of Houdini. This is a new duplicate scene. I just deleted all the AOVs, so we can only focus on the deep AOVs. And also the name will be a little different when I render this out using tops. So what we need to do is go to the AOV processing tab, and here we have our deep AOV section. By default, this is disabled. We're going to turn it on. The deep merge is mesh ID, object ID. These are less accurate. Z is, if you want accuracy, stick to Z. If you're wondering what deep merge Z threshold means, recommend you guys read up about it in the documentation. But what it basically means is the per pixel quality of depth for the points that get generated using deep data. So adjusting this value will give you higher or lower resolution. You can think of it that way. If there's depth of field or motion blur, stuff like that. So they kind of give you some examples here of little points, less points. And so what you could think of is it like a irradiance point cloud or irradiance cache, where pixels get averaged and merged together. That's what this is doing. So the higher or the lower the value, the more accurate or lower accuracy this will give you. By default, this is kind of high quality, the 0.01. So it's not merging a lot of points, and they give you a little nuke example. and you can increase or decrease the threshold. So here it's saying if they use 0.1, you'll get fewer samples and the file size will decrease. Now that's one thing to keep in mind, guys. Deep data is very, very file size heavy. It's huge. And so it can quickly turn into gigs and gigs of data very easily. So yeah, if you don't need that much data, increase this number and the accuracy will merge points, or keep it at default, or go lower if you truly need it, which you probably won't, but if you do, that's an option. So think of this kind of like the adaptive error threshold. The smaller the number, the better the quality, and the larger the number, the less quality you get in your sample point data. So anyways, let's move on. We're going to just keep it at default. So now that it's enabled, the other thing to keep in mind is Redshift only stores the beauty, depth, and object ID. That's it. Hopefully in the future, now that 3.0 is going to launch soon, with deeper trace depths and stuff, we'll be able to get volumes and other important AOVs, but as deep data, which will be very, very powerful for larger pipelines and studios that need those kind of features, and even for smaller studios that need better compositing tools. So we're going to just make the object ID and depth. So we're going to make 2 AOVs. We're going to come over here to zdepth and object ID, and that's about it. I mean, there's not much else to it. And so if we render this shot out, and I could render multiple frames, but you know what, guys, it's just huge data and it's slower to render. So I'm going to just stick to 1 frame because the example will work in Nuke. So cool, let's render this out. Hey guys, I just found a bug that is inside of Houdini, so I just reported this, so hopefully this gets fixed in the next version. It has to do with post effects in Deep. It's only in Houdini, so if you're working in Maya or any other app, it should work fine, but unfortunately in Houdini there's this bug. So to get post effects working, we need to do a couple things. I mean, not post effects, Deep working. We need to make sure the denoiser's off. I forgot to turn this off earlier, actually. And we need to make sure that our multi-layer is off. Because if you have multi-layer, it will automatically disable deep output. So make sure this is off. I forgot to turn this off earlier too. But now here's where the bug kicks in. In Houdini, for some reason, if you have any of these options activated, it will crash the deep output and crash Houdini. So make sure to disable this. You don't have to worry about this in Maya or the other apps. Hopefully, like I said, next build they'll fix this since I reported it. And yeah, so now we're good to go. So just disable this if you're still using Redshift 2.639. I'm hoping by 40 or 3.0 this is already fixed. And yeah, just make sure to disable denoising, enable deep. We'll just use the defaults like we had earlier. Only 2 render layers work, zdepth and object ID. I'm not really going to use them because there's just really not much of a purpose, but you know, it's good to have them in case you do need them. And yeah, we'll just stick to 32-bit float. We could use compression. I'm just going to keep it to none. Actually, let's just do zip. And yeah, that now it's good to go. No multi-layer. And so this will render out a deep file. It's pretty big compared to a regular file, so just so you guys know. And actually, we'll use zips. So, all right, cool. and I might make an animation, but I'll only include one of the EXRs just because for all of these shots, just because I don't want to make the 7-zip file that I upload gigs of data. I'll see how big it is at the end, but yeah, I just don't want to make the file you guys have to download later too big by including all the frames. So let's batch render this out and see what we get in Nuke. Alright guys, here we are inside of Nuke, and here's some of our renders. And just like I mentioned to you guys, the file sizes can get pretty big. I mean, these are 40 megs to 20 megs, and this is only a 720p file with only 2 AOVs. And if you compare that to our other renders, which are in similar size, these had tons of AOVs, and this is just basically the deep data that's taking up all that space. So keep that in mind, that if you do work with deep, bigger resolutions, tons of frames, be prepared to use gigabytes of data. But deep does come with some pretty neat benefits. So in order to work with deep has its own special input nodes. If you come up here on the shelf, this is a collection of all the deep nodes. So there's deep color correct, crop, deep from frames, deep from image, etc., etc. And these deep nodes, you could just type deep when you hit the tab key and bring them in. So we're going to bring in our render. So you need to use a deep read. And in here, we should have our deep render right here, 1 through 10. And all deep nodes are blue. They're like that's like a special designation. And we're going to load them in. And it'll look essentially the same, nothing particularly special about them. And actually, my resolution's a little low. Or not my resolution, my sample settings. So I'm going to re-render this real quick and load it back in, just because I want a little cleaner render so you guys can see what's happening a little better. So I'll be back. Alright guys, I'm back. Rendered out the shot again so it's a little cleaner. And just so you guys know, just in increasing the quality, we also got bigger file sizes. So now we're in the 50 megabyte range. And the reason is because more pixel sample data was taken. And as you can see, we're getting still some flickering in our motion blur here. But I didn't want to render too high quality because it would have taken longer. This is good enough though, so you guys can see what's happening. And we've got motion blur built in to our shot. As it moves around. Okay, cool. So here we've got motion blur baked in, and we've got our deep render here. So what can we do with deep? There's several things we could do that are pretty neat. What makes it really powerful is the ability to composite things without using mats or masks. And I'll actually show you guys an example of that. Kind of like what we did earlier with the World Pass AOV and the normal, where we made a point cloud. So if we actually, let's bring up deep to points. Let's plug that in, and let's make a camera. And let's use that same camera we made earlier. So we should have, here's our render cam alembic. Plug that in, and let's check out the deep render. You'll notice this is what we got. So very similar to what we had earlier, where we had the point cloud. Let's look through the camera. Which is pretty neat. And so if we move around here, it's very similar in fashion. We've got points settings. If we click on the points data. We don't want to render any of it, so we'll just keep that off. And we have the point detail. So if we zoom in here, oops. Let's click away. You'll notice that we've got all our little points. And you could use this to composite things in. And obviously we can increase the point resolution so you get a little better idea of what's going on. You can change the point size and so on. And so, just like we had earlier, we could use this to help guide a composite. What's neat about this, though, is we get way more information. We get, I mean, look how much cleaner and sharper our edges are. So we really get a good idea of what we're compositing. And so Deep, it's been around for maybe, I don't know, 10 years or so, but it's really been picking up lately in modern pipelines, especially for compositing volumes. Unfortunately, Redshift doesn't support deep volumes yet, but speaking to the devs about it, that's one of the planned things to get added in 3.0 now that we have larger trace steps and stuff being added. So what makes it really powerful is you can just drop in volumes from a render and it'll feel like it belongs inside the render. And what do I mean by that? Let's bring in our card like we had earlier. So let's make a checker, and we'll format this to 720p, which is our scenes format. Let's drop down a card. Here, and let's hook it up to our camera. And our card format, let's make that 720p also. And we should be able to see our card somewhere. Here we go. And let's scale this to, let's do 2. Cool. So now we've got our card in 3D space. And as I mentioned, you guys could imagine yourselves using tons of other stuff, you know, cards with fire or whatever. And actually, I'm gonna lower the resolution just because it's too many points, and I want a smoother viewport feedback. So let's do 0.5. Actually, no, let's do 0.25. That's, I don't need that much detail on our points to see where it's being laid out. And now it's a lot more snappy. So let's position our card into 3D space. And let's actually look through our camera. And let's just say we're going to put it, I don't know, right there. So what's neat about this is deep data has pixels in distance. So it calculates the distance of pixels in Z space in your render in the EXR, not just the flat pixel value. So like we had earlier, we had to use a mat to cut out this cube, right? This time using deep data, and actually let's merge this down. Oops, not a regular merge. We need a deep merge. And so, like I mentioned earlier, deep has a lot of its own special nodes. And if we use the deep merge, this obviously merges deep data. So we're going to merge back in. We're going to make this our background, our original render, and we need to convert this checkerboard card into something deep. Because right now, if we try to connect it, it doesn't work. And the reason is because our card data is not a deep file yet. So there's a special node called deep from image, and this will convert your image into deep data. And now if we combine that, boom, got our deep node in here, our checkerboard in deep space. So if we zoom in, it blends right in, and there is no mask, no matte, nothing involved. So if we move around, it perfectly layers it into that spot, which is awesome. And that's basically the true power of deep. And even though our scene has motion blur and stuff, and obviously this doesn't have motion blur, I would have to add it, but you get the idea. It composites it perfectly in there, even with motion blur. So what if we let's copy this. Actually, let's just move it so you guys can see what happens here. If I move it, back here, even though there's motion blur, look at this, perfect cutout. Let's just hit play. I mean, look at that. No masks, no mattes, nothing to deal with. Even though there's motion blur, our asset composited in perfectly. And that's the beauty of deep. It lets you composite different renders or different assets, even with motion blur, even in depth of field, doesn't matter. Deep just is deep, and it works 90% of the time. The problem with it is the massive file sizes. So that's pretty much it. Pretty neat. So what else can we do here? Let's say we wanted to composite, I don't know, some other elements. And like I said, we don't have deep volume support, unfortunately, which would be the coolest use for this. But you could do other things with it. For example, let's make a P snow box, or it could be a rain box. Yeah, let's do a rain box. Actually, no. Let's do a snow box. And you could load up an image with this, or you can bring it into a scene. What we're going to do, let's make a scene. Connect this in. And our camera out. We probably need another camera. Let's copy paste that in. And if you don't know what the here, I'll just show you guys what that is. That's a snow generator. Can't really see it too well. Let's make the scale a little bigger. So you can see these little points. It's kind of hard to see. But inside this box, it's raining snow. It's one of the particle systems inside of Nuke. Well, anyways, the idea here is that you can render this out as deep. So if we make a scan line or deep, yeah, let's do a scan line. render. And so we've got our object slash scene. We plug that in. And actually, let's remove that camera, plug it in over here. So if you look at this, we've got this shot here, and we want it to cover our scene, so let's make the cube a little bigger. Let's see, where was it? Let's do 4 in X, 4 in Z, and that should cover our scene mostly. Yeah, it's a little too big, but that's fine, whatever. We want it to cover the entire shot. And let's come back in here. So now we've got this falling snow. Okay, cool. And we need to write this data out. So there's a special deep write, just like there's a deep read. And this lets you write out deep data from your shot. And so you could write out deep data. I'm going to give it a folder to write out to. Let's see, deep snow. So this location, and we'll call it deep snow 4 frame hashes .exr. And this will let us write out this data in deep space, which is pretty neat. And I already have it written out, but I'm going to just rewrite it out. It's simple, so it shouldn't take too long to write this data out. And actually, before I write this out, let's save our scene just in case. Because you never know, anything could happen. And before we actually write out our render here, let's zoom in. We could try to increase the shutter to get motion blur on our render. I don't remember what I had this set at actually in Redshift. Let me jump into Houdini and check that real quick. And it appears I had this set to 1 in Redshift, and let's increase our samples to 3. And there we go, we've got a little bit of motion blur. Maybe make it a little stronger if you want. That might be too much actually, so let's keep it at 1. And that'll just give us a little pinch of motion blur. And obviously if we wanted to add motion blur also to our card, we would need to write this out as a deep write the same way that we're doing here. In fact, we can do that right now also by unhooking. Well, no, we could keep it's the same camera, so we'll just keep the same camera. Or actually, no, let's unhook it. And we're going to move this over here. Get rid of our deep from image. Delete that. And we're just going to add it to our scene. Sorry guys, an airplane just flew by. I had to pause it. And why is this not merging into our scene? What's going on here? Camera. Huh. And I just realized that the card 3D node does not work with a deep write, so I actually need just a regular card. So let's delete that real quick, make that a card, and then we'll pipe that back into our scene. And now you can see that it's showing up in here. And so if we look through our camera now, and actually let's do a let's unhook this. Well, it doesn't matter. I mean, it's the same thing. So let's do a deep reformat. This lets you reformat the deep file. And we're going to reformat this to 720p. And we'll move down here. And let's do a deep merge. Or actually, we already have a deep merge. So let's bring this down. And then this to the side. And we'll merge the deep reformat in. And we'll check out our points, and our points are a little too big from the looks of it. Yeah, they look way too big. So let's come back up to our snowbox. That's still too big. And actually let's see here, our snowbox might be too large also. Yeah, it looks like it's too big. So let's decrease our snowbox scale. Let's do 3 and 3. And let's decrease our flake scale even further. Let's do 0.1. Give it a second. Okay, that's still too big. 0.2. Let's just see what happens. That might be a little better from the looks of it. It's actually too small. Well, no, I think that'll be okay. Yeah, we'll get some falling flakes just to have something in there. And now we need to move our card. Let's hit tab. And I actually need to write these to disk. But let's lay out our card first. Where is it? Let's move that up. Let's make our card scale. Let's make it 2. Let's move it to the side. And let's see what this looks like in the scan line render. So as you can see, there's motion blur now being applied. I'm not seeing my snow anymore. So I'm thinking the points might be a little too small again. So let's come up to the snow box. Let's actually bring back our scale to 4. Make sure everything's in there. And do a flake scale of 0.1. Two, 5. Okay, they're showing up now. They're just really subtle. And I think the motion blur is also killing off the points. Okay, they're there. Cool. So now what we can do is write this out so that it's not loading live like we've been doing it. And so we'll cache this out to disk. So let's come to our deep right and hit render. And actually, let's do 32-bit float. We could keep zip. That'll be fine, I think. And yeah, let's cache this out. So yep, write it out. So I'm gonna pause this while this writes these. It'll be quick, but still, I'll pause it. And it finished caching out, but I wanted to quickly show you guys the problem with deep in Redshift is, as you can see, the volume is flat on the ground, unlike the geometry. So yeah, that's what I meant by Redshift doesn't support deep volumes. So it doesn't give a 3D space. So I can't move a card inside of the volume like I can behind stuff over here. So that's what I meant, guys. Hopefully, like I said, this gets added soon because that's really powerful stuff. So anyways, let's moving on. Let's bring in our file that we wrote. So deep read. And let's jump up a level. And let's read in our deep file. Where are they? Nope. Let's go back up another level. Deep snow. And here we go. So here's our deep file that we made earlier. 720p. Actually, let me make sure. Okay, yeah, so it did write it out. Actually, we need to reformat that, so. Well, no. We'll use the proxy format, and we'll move. We'll unhook this, move it on up, plug it into our deep read, and there you go. Now we've got our baked in checkerboard asset and our snow falling with motion blur. Sampling on the motion blur was kind of bad on the scanline render. I should have increased it to 5 or something if I wanted it to be smoother. But you get the idea, guys. You could see that I didn't use any masks, no mats, nothing, and it got motion blurred in and everything. And we've got our snow falling, doing its thing, and it will fall behind and in front of objects. So you can see this piece right here goes behind. Oh no, it's actually in front. But some of them will go behind and some of them will go in front. So you get that perfect composite with motion blur and everything. No mats or masks to have to worry about, which is great. And so yeah, I think that kind of gives you guys a little summary of how to use deep with Redshift and how to bring it into Nuke and what it kind of can do and some of the power that deep provides. Yeah, I think that just about covers it. There's another really useful node is the deep sample. So what this node lets you do is it lets you, and I'm not sure why it's not showing, and the reason it's not showing is because overlay's off. So right click, hit Q, and you'll see this little thing right here in the corner, and that's like a sample picker for the deep sample. So if you move this around, you'll notice these values start showing up, and the min z and max z is kind of like the distance from the camera to the sampled point. See that? So it's pretty useful if you need to get an exact position and distance from an object, right? Which can help you when you're compositing stuff. Yeah, I think that about covers it. And the merge node has combine or hold out. If we do hold out, it cuts out. It's a holdout. It cuts out the pixels of the object that was there. So that's what holdout mode does. And yeah, I think that gives you guys a good idea. So that about covers most of the AOVs and how to use them in Redshift that work, at least, and are usable in normal day-to-day work. Hopefully you guys learned something new and you could apply some of this knowledge yourselves in your own projects. I just want to say thanks again for supporting my Patreon. I really appreciate it.